Hey guys, today we're going to be talking about using similar figures, and this goes with the learning goal. I can use proportions to solve problems. So first of all, we need to know what similar figures are, and before we do that, we're going to talk about what a polygon is, and this should be a review of things that you've talked about in years past. A polygon is just a closed figure formed by 3 or more line segments that do not cross. So you can't have curved sides, you can't have gaps in it, and you can't have any sides that cross. So pretty much any of the geometric shapes that you can think of would be polygons, except for a circle is not a polygon, but like a square, rectangle, hexagon, pentagon, all of those things are polygons. So similar polygons are 2 polygons that have corresponding angles that are congruent and corresponding sides that are proportional. Blah. Big mouthful there. So we need to know what they mean by corresponding, and then congruent just means equal or the same, and proportional just means forming a proportion. So let's look at what that means. So corresponding sides and corresponding angles are the ones that would line up if we take 2 similar figures and set them so that they're facing the same way, basically. So I have these 2 triangles down here, and you can see that if I took this triangle and I blew it up, I could make it be the exact same size and shape as that original triangle. So it's like, similar polygons are like if you enlarge or reduce a figure. It stays the same shape, but it's just a different size. Now these angles, if you look and I line up that angle, or that angle, or that angle, those are all the same size. So that's why we say that those angles are congruent. They're the same size. And you can see that I have these 2 triangles facing the same way. Now if I flipped this one around, then I wouldn't have the same angles lining up, but I could still figure out which angles correspond to each other. I could see that this angle down here at the bottom corresponds to this angle up here at the top. So you just have to think about, if they were facing the exact same way, how would they line up? And then the corresponding sides are the sides that match up. So notice here that if I write ratios of the different sides that correspond to each other, for example, this side and this side, I could write a ratio of 5 to 15. Or if I did the sides that correspond to each other here, I could write a ratio of 4 to 12. Finally, I could write a ratio of the bottom 2 sides, and that would be a ratio of 6 to 18. And there's lots of ways of showing that those are equal to each other. We could use any of the ways, change them to decimals, simplify them, or cross multiply, and we would show that those are all equal. So I'm just going to go ahead and simplify these really quick. 5/15 simplifies to 1/3 if I divide both of those by 5. 4/12 simplifies to 1 to 3 if I divide both of those by 4, and 6/18 also simplifies to 1 to 3 if I divide both of those by 6. So you can see those are all equal ratios, so any 2 of them together would form a proportion, and that's why we say that those sides are proportional. The answer to the free response question for today is
52 card pickup. 52 card pickup. Don't erase that.
So now I can use the information that corresponding sides in similar figures are proportional to find any side lengths that are missing. And I can do that by setting up ratios of 2 sides that I know the lengths of that correspond to each other, and then I know that any ratio that I set up with the missing side length and its corresponding side will be equal to that. So that'll be a proportion, and I can just solve it. Now I have to be careful when I do this that I'm actually matching up the corresponding sides. And notice that the figure on the left here is a reverse of the figure on the right. So when I look at this, I would have to kind of flip it over in my mind and notice that the top 2 sides correspond to each other, and the bottom 2 sides correspond to each other. But then since it's a mirror image, this side corresponds with that side, and this side corresponds with that side. So I can set up any ratio that I want, like I said, of 2 sides that correspond to each other. So I could set up 8 to 4 from these 2 sides right here, and then I could set up notice that I've put the side length of the bigger trapezoid on top and the smaller trapezoid on the bottom, so I want to do that when I'm setting up my other ratio so that I have it set up the same way and I get an equal ratio. So I would have the side length of the larger trapezoid that corresponds to the x in the smaller trapezoid. And then to solve that, I would just cross multiply, find the cross products. So 8 times x is 8x, and 4 times 7 is 28. And when I divide by 8, I will get x equals, not a whole number, so I'm going to do this on my calculator. 28 divided by 8 gives me 3.5. So the side length x is 3.5. So I could write that over here now. I know that x equals 3.5. And another thing you might notice is that all of the side lengths on the larger trapezoid are twice as long as all of the side lengths on the smaller trapezoid. And so you could also have solved this using mental math and just say, well, I noticed that the top ones are half, so half of 7 is 3.5, so x has to be 3.5. Another way that we can use similar figures, and this is actually something that they do in real life, surveyors use this, and then you can use this indirect measurement for lots of different things. Let's say you have a tree in your backyard that you're going to cut down. It's old and dead and you want to cut it down, and you need to know how tall the tree is so you know whether or not it's going to crash into your house when you cut it down, in case it falls the wrong way. It's really hard to climb to the very top of the tree and then hold a line down and get an exact measurement of the height of the tree. So it's much easier, you don't have to climb the tree, to use indirect measurement. And the way that we do that is by noticing that if I hold something that I know the height of up, and this only works on a sunny day, so you'll have to wait for a sunny day to figure out the height of your tree. You hold that up and you know its height, and then you measure the length of the shadow that that item casts, and then you measure the length of the shadow of the tree. Then you can, using similar figures and proportional thinking, you can figure out the height of the tree, because these two right triangles are similar to each other. So notice that it says it's a yardstick that you're holding up, and a yard is 3 feet high. So I know that the height of that figure over there is 3 feet, and the shadow that it's casting is 2.5 feet. So I am going to write a ratio of the height of the item, 3 feet, to the length of its shadow, 2.5 feet. And then I would go over and I would measure the length of the shadow of the tree. And so this was my shadow over here on the bottom, so I'm also going to put the length of the shadow of the tree on the bottom of the ratio on the right side. And that one we measured to be 16 feet. And so the height of the tree is what we don't know, and so I'm going to put a variable in for that. And now I will just cross multiply to solve this. Multiply that way and that way. So I get 2.5 h equals 48. And so now I need to divide both sides by 2.5, and I get h equals, I'm going to do this on my calculator, 19.2 feet. So now I know that the height of my tree is 19.2 feet, and I can make a decision about whether or not I should cut it down or not, or whether or not I need to climb up and cut off the top of the tree first.
Wow, Mom, proportions are really useful.
Here are your free response and multiple choice questions. So pause the video now and answer those, and then have a fabulous rest of your day.